All right, continuing with section 1.3. This is about different sampling methods. So the first one, and the one that I think is kind of the easiest to understand, is systematic sampling. So this is where you select some starting point and then select every kth element in the population. So let's say, I'm trying to think up some numbers that are easy to work with. Let's say that your population is 4,000 people and you want to collect a sample of 100 people. 4,000 divided by 100 is 40. So what you would do is you would randomly pick a number from 1 to 40, let's say 17. You would pick the 17th person, and then you would pick every 40th person after that. So 17, 57, 97, et cetera, et cetera, et cetera. So by the time you get all the way through, you'd have 100 people, okay? And if the population is just in some random order, then you should get a nice random sample out of that, okay? That's called systematic sampling. All right, the next one is called convenience sampling. So this is something that you do, you know, sort of when you don't have any better way to do it. You have to be really careful doing it this way. Standing in front of the library conducting a survey would be convenience sampling. You're just going to grab the first 100 people that walk by. I remember using standing in front of the library asking people questions as an example. Last week, you wouldn't want to ask them questions about, you know, how do you feel about the college's plan to cut library hours, right? Because people that you're likely to see in front of the library are not going to necessarily have a representative opinion on that. You know, maybe you're going to stand in front of the library asking, you know, would you like to see Merced College offer more childcare? Okay, that would probably be a little better because it's sort of not related to the place that you're standing. Okay. All right, so we have systematic sampling, we have convenience sampling. Next we have stratified sampling. This is where it gets a little confusing. There's something called stratified sampling, and then there's something called cluster sampling. And those two sound kind of similar. So stratified sampling is where you subdivide the population into at least 2 different subgroups called strata. Strata is a Latin word that means layers. So that the subjects within the same subgroups share the same characteristics. Then draw a sample from each subgroup, okay? So in the example they have here, they've divided the population into men and women. They're going to select a certain number of men and then select a certain number of women. Okay. All right, here's cluster sampling. Divide the population into sections, which are called clusters, and then randomly select some of those clusters, as in all of the elements within a cluster. You select all of them, okay? So let me try to help you understand the difference between stratified sampling and cluster sampling. So again, stratified sampling, you divide the population into, say, men and women. You select a certain number of men and then select a certain number of women. Cluster sampling would be like, let's say that right now at this moment at Merced College, there are 125 classes being conducted, right? This is one of them here in Voc 112. We've got a few over in the science building. We've got some over in IAC. And most of them are a mix of men and women. So another way to do sampling is you just decide, okay, I am going to randomly pick 20 of those classes. I'm going to pick all the people in Voc 112. I'm going to pick all the people in Science 208. I'm going to pick all the people in IAC 144. All right, and that's another way to do sampling. Okay, so hopefully you see the difference between that and stratified sampling. Okay, and then I believe this is the last one. This is called multi-stage sampling. So this is just where you use maybe 2 or more of the methods that we just talked about. In a multi-stage sample design, pollsters select a sample in different stages, and each stage might use different methods of sampling. Okay. So when you go to do your homework, I believe there will be some scenarios. You know, sample was collected this way, and then they're going to ask you what sampling method is that? Is it systematic? Is it convenience? Is it stratified? Is it cluster? Or is it multistage? Okay, observational studies versus experiments. I feel like we talked about this already. So in an observational study, you're observing and measuring, but not modifying. You are not interacting with the subjects. You're not trying to control their behavior. You're just watching, basically. Oops. So some different types of observational studies. You have cross-sectional studies where data are observed, measured, and collected at one point in time, as opposed to over a period of time. A retrospective study. Data are collected from a past time period by going back in time, by examining records, doing interviews, stuff like that. And then you have a perspective, often called a longitudinal study, where data are collected in the future from groups sharing common factors called cohorts. So when I think of a cohort, I think of a group that sticks together. One way we use it here at Merced College is over in the CTE area, the career technical ed, like in the welding program. They also do it in the nursing program. Students move through the program together and take all of their classes together, right? So if you're, looking to study aspects of that group, you would follow them through whatever it is they're doing. Okay. All right, let's see. All right, continuing with the vocabulary of chapter 1, lots of vocabulary in chapter 1. Confounding occurs in an experiment where when the experimenter is not able to distinguish between the effects of different factors. So here's something you may not know about me. Before I became a math major, I was a psychology major. I decided later to become a math major. Actually, when I was taking a statistics class, so you might hear that story later in the semester. So this is something that I've always thought is an impressive skill for people who study things like psychology. You have to make sure when you're designing an experiment that there's not too many different factors that could affect things. So, you may decide, I can't think of a really good example off the top of my head, but, students who study more did better on the exam. And it may turn out that those same students who studied more were also using tutoring, all right? So you just want to make sure that there's really only one effect that could explain the change that you're seeing, okay? And that I've always thought that that's sometimes really challenging to do, okay? But people who do psychology, for example, know how to do that. Scientists also know how to do that. All right, completely randomized experimental design is where you assign subjects to different treatment groups through a process of random selection. So you're not going to choose who gets what treatment, you're going to do it at random. Randomized block design. A block is a group of subjects that are similar, but blocks differ in ways that might affect the outcome of the experiment. Okay, then we have matched pairs design, where you compare two treatment groups by using subjects matched in pairs that are somehow related or have similar characteristics. A rigorously controlled design is where you carefully assign subjects to different treatment groups so that those given each treatment are similar in ways that are important to the experiment. And I don't mind telling you that some of this vocabulary is going to be more important to me than other parts of it, right? I probably won't make too big a deal about experimental design, for example. If you take, we offer a psychology version of this class called Psych 5, and that when you take the class in that format, they make it a lot more sort of relatable to psychology, and there you might see a little bit more of this stuff. Okay, and that brings us to sampling errors. No matter how well you plan and execute the sample collection process, there is likely to be some error. So sampling error occurs when the sample has been selected with a random method, but there is a discrepancy between a sample result and the true population result. And this is something that just happens, okay? Your sample hardly ever exactly matches your population because the sample is not the same group as your population, okay? Hopefully, if you choose a large enough sample and you choose it using a good method, it'll be pretty close, all right? And that's something that we're going to be talking about more later in the semester. I think there might be a whole chapter about that, actually. Non-sampling error is the result of human error, including such factors as wrong data entries, computing errors, questions with biased wording, false data provided by respondents, forming biased conclusions, or applying statistical methods that are not appropriate for the circumstances. So those are things that you can hopefully help, all right? Sampling error, you can't help too much, except, you know, if possible, to choose a larger sample. That's the best way to get around sampling error. These are things that are sort of all under the control of either you or your subjects. Non-random sampling error is the result of using a sampling method that is not random, such as that voluntary response sample that we talked about, right? Internet polls, terrible. Don't use them for anything serious, okay? Convenience sampling is not as bad as voluntary response, but it's still not the best way to collect a sample unless you're really, really careful. And that is the end of section 1.3 and chapter 1.